You definitely wouldn't consider yourself a runner. The idea of running for fun is preposterous. But you do on occasion run. The motivation is to catch something, maybe your toddler, the elevator doors, or a bus. Thankfully, you don't have to run to catch your dinner. You know, to keep running, you need air. As long as you can match oxygen in with oxygen use, well, you can keep going. And how fit you are determines how far you can go before you run out of air. But being breathless is something we've all experienced. It's unpleasant, but it's not the same as suffocating. Scientists from the Pennington Biomedical Research Center in Baton Rouge think this is how fat cells in obese people frequently feel. They're breathless. There is oxygen around, but not quite enough to feel comfortable. But they're not actually suffocating or hypoxic. Join us with this episode of Better Body Chemistry TV to find out why your fat cells might need help catching their breath. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. The team set about trying to catch fat cells breathing inside people. As you can imagine, this was not an easy task. To do this, they needed to access fat cells inside people. Fortunately, they managed to find 24 people prepared to sacrifice a few fat cells and endure a lot of poking and prodding for their worthy cause. 12 of the people were fatties. Average BMI was 31.7. 12 of the people were skinnies. Average BMI was 22.1. All were healthy on the outside. They were not taking any medications that could possibly interfere with their fat cell vitality. As expected, the fatties were more insulin resistant and had a lot more fat cells. The fat cells the team borrowed came from deep inside the volunteers' bellies. The same spot was accessed in all the volunteers. Before pinching the fat sample, the adipose tissue was explored using fancy probes that were able to measure oxygen levels and temperature. The fat cells living inside big bellies were not getting quite as much oxygen as those inside skinny bellies. They weren't suffocating, but there was a difference. Enough to matter? Probably. When the team examined the fat biopsies, the reason for the breathlessness was obvious. The fat cells taken from the fat bellies had fewer blood vessels attending to their oxygen requirements. The problem? Rarefaction or capillary dropout. Shame. These little guys were running for the bus, but weren't getting their oxygen needs taken care of. No wonder they're upset and not working at their best. It's generally accepted that the metabolic troubles associated with obesity happen when there's low-grade inflammation present, and fat cells are blamed for this inflammation because they're the source of pro-inflammatory chemicals causing all the troubles. But why are they spewing out these chemicals? The short answer is usually they're too full. That is, you ate too much and moved too little. But hang on a minute. Storing fat is what they do. Surely they would be able to expand to meet the demand. Why can't they store those excess calories in you? Maybe it's because they're breathless. All they need is a moment or two to catch their breath. Can you help? Yes and no. To really solve their problems, you need to grow more blood vessels and expand your capillary beds. And this is not so easy to do, but it can be done. Actually, this is one of the things glitazones do. Glitazones are meds used to treat type 2 diabetes. The category of drug includes pioglitazone, better known as Actos, and rosiglitazone, better known as Avandia. The way these drugs work is they turn on a whole bunch of genes because they act like a nuclear transcription factor. Since PPAR is a very busy nuclear transcription factor, it controls lipid and glucose metabolism. Switching this on changes the metabolism of fat cells. One of the ways that it does this is it causes vascular endothelial growth factor, or VEGF for short, to be released. So what does vascular endothelium growth factor do? It grows vascular endothelium. That is, it grows new blood vessels. And more blood vessels improve the oxygen supply, helping fat cells to be a little less breathless and a little happier. So growing more blood vessels is one strategy to make fat cells happy. You might be wondering, can't we use the blood vessels you've already got to supply fat cells with more oxygen? Now, to reach out and grab an oxygen molecule, it helps if you are in close proximity to a blood vessel. Of course, the bigger a fat cell is, the harder it's going to be to reach out and grab those oxygen molecules as they float by, because they're just that little bit further away. But if you can shrink the fat cell just a little by losing some weight, it will end up being a little closer to a blood vessel, making grabbing that all-important oxygen a little easier, and that fat cell a little happier. If you need some help emptying your fat cells, be sure to download our free report. It gives you 10 biological weapons you can use against your sugar gremlin, who more often than not is behind those extra pounds. So, losing weight is one way to bring relief to breathless fat cells, but it's not the only way. You could also work at improving oxygen delivery. Exercise will do this, and so will increasing your nitric oxide levels. Begin the journey today to better body chemistry. visit our website at www.betterbodychemistry.com. Browse our library or sign up for our newsletter. The advice is simple to follow and based on real science, not hype. Know someone whose fat cells might be breathless? Share this video with them so they know how to help them breathe easier. And if you enjoyed the video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.